Hello, everyone, and welcome back to the course. So, in this lecture, we are going to study two new things, something called correlation and covariance. Okay. So, what are these two things? So, what's the difference between these two things? So, simply from the title here, we are measuring the relationships between two variables. Okay. Now, let's try to get a bit deeper here. Okay. Now, what is a correlation between two variables? So, what if I tell you that there is a high correlation between you exercising and you losing weight? It means that uh, these two things, exercising and losing weight, are directly proportional together. So it means that if you exercise a lot, the more you exercise, the more weight you will lose, or let's say the more fat you will lose, to be more accurate. Okay, okay. This applies to anything. Okay, so around you, think about anything around you. You will find that there is a correlation between you and these things. So let's say another example. You would be able to do a big amount of effort in the day if you slept very well. So the better you sleep, the more exercise you, the more effort and the more focus you will be. This is a high correlation. So let's go a bit deeper. Now, first of all, covariance. Covariance is measuring how two variables are changing together. Okay. Now, what does this mean? It means that we have two variables. This could be two columns inside our data set, and we are measuring the relationship between these two columns and how they change together. Okay, great. Now, do they highly correlated to each other? And keep in mind one thing: negative correlation doesn't mean bad thing. Okay, so I'll tell you here. Uh, Here we have the equation of the covariance. The covariance is summation or the sum of x. Okay, so here we will assume that x is the first column and y is the second column, and we want to measure the correlation between these two. So assume x is the first, y is the second, and I want to measure the correlation. Now, how can I measure the correlation in this case? First of all, I'm gonna do two terms. The first term is this one, x. So for each value of x, we are going to subtract it from the mean of this x of this column, and so we multiply them together with the y or the other variable subtracted from its mean as well. And we divide by the total amount of data that we have. Okay, good. This will give us a number. So this number could be a positive, could be a negative, and could be zero. So if it's zero, it means there is no relationship, no linear relationship. They are not increasing together. There is nothing like they are completely not related to each other. I'll give you an example of that. Zero relationship. Let's say some like a economic problem happened in, I don't know, happened in a country in South America or Latin America, and you are living in, I don't know, maybe in Germany. So there is a zero correlation here. Okay, so this economic problem will not affect you, and if it will affect you, it will affect you very slightly. So we consider this a zero relationship. Now, if we get a positive number, which means that both increase together. So this is the example we give. The more exercise you do, the more muscle you gain. This is a positive correlation. Negative correlation means uh, one thing increase and the other thing decrease. It also, let's go again also to the exercise. So if you exercise more, you will lose weight. Sorry, you will lose fats. So this means that they are having negative covariance or negative correlation together. Okay, good. Let's take an example here. Okay, we are going to implement this, guys. So don't worry about implementation. Okay, now let's take up this example. So you have in this example, you have some data for hours studied and test scores. This is a very simple example. How many hours did you study? So we have X as a column and Y as another column. So X is 1, 2, 3, 4. And Y is 50, 60, 70, 80. Now, each Consider this a data frame, or consider this an Excel file, or a CSV, or a table. So the person who studied 1 hour got 50, person who studied 2 hours got 60, 3 hours 70, 4 hours got 80. Do you think this is a positive or negative correlation? Or covariance? Let's say covariance. This is a positive or negative? It's clearly from the data that we have here, it's a positive covariance, right? Now, why? Because the more hours you study, the better score you will get. How this could help us in the data? This will help us by understanding the behavior of the students. So in this case, we understand, I mean, this is obvious problem, but it doesn't necessarily means, I mean, I want just to explain the concept with this problem. So in this case, we have only two columns of the data. The hours studied are increasing, and the more increasing the hours, the more test scores we are getting, which means that obviously the more hours you study, the more test scores you will get, which is very obvious, which means that to get good scores, you must study for more hours. Okay, we might add some more variables in this data. So maybe the weather, let's say an example is the weather, let's say. So the weather, we can see different pattern in this case, and imagine any other pattern. So could help us identifying and knowing that, okay, as an example, students who study maybe in winter are getting better grades than the ones who study in summer, or the opposite. So we're going to see some examples later in the later lectures. We're going to see more detailed examples. But for now, let's stick to this one, a very clear and straightforward one. So the equation tells us that we first of all need to get the mean. This x with a hat on it means the mean. This y with a hat on it means the mean. So we are not using the symbol of mu that we used in previous lecture, because here we have two means, so we need to distinguish which one belongs to which data. So x with a hat is the mean of x, y with a hat is the mean of y. So to get these two, as a first step, we got the mean of the first one, 1, 2, 3, 4. The average of these values is 2.5, and the average of my test scores are 65. So the deviation, I have done all the calculations here for you, so you don't need to do anything, but I just wanted you to know how we calculate the covariance. So so we calculate each like term of these. So this one multiplied by this one, and then this one multiplied by this one, and so on. And then we add all of them together, divide by n, which we are doing here. We get the values, and finally we divide it by n, which is the number of data that we have. And that's why we always need to have consistent number of data. Okay, if we have here one value more, we would replace it here by 0. If we have a missing data, we will deal with missing data later. But for now, the covariance we got is 12.5, which is positive. Now, this is good. Yeah, so it's positive. Okay. But did you notice anything here strange, or something doesn't make sense? Yes. So what is not making sense here is that this value, you don't have really a reference for this value. So how much could I say it's positive, highly positive, or low positive? Besides, like, if we got 50, we got 100, we got 120, is it the same as we got 10 or 15 or 20? Now, you may ask this question, right? If you got like a bigger number or a smaller number, how could you identify that this is like a higher covariance or lower covariance? Because it doesn't necessarily mean that. Now, let me tell you this in another way. You see the values of the data here. So the values are not normalized, right? So what do we mean by normalized? So these are like 1, 2, 3, 4, and these are in 50, 60, 70, 80. So there's a big gap or a big difference between them. So covariance method highly dependent on the data and how the data is represented. It doesn't care really about the data is like how the data is represented, and this affects the numbers. So the covariance that you are getting here might be a bit, confusing, because you really don't know, like, it's not really an indication that this is a high. It's okay, we know it's positive, but we don't know if it's a high covariance or not. In this case, it's a clear yes, but for bigger data sets, it's very difficult to identify that, right? So this is the limitation. The covariance values are not standardized. And to give you a better and clear example here, you can see that covariance, an example that we got the height and the weight. So height in centimeters and weight in kilogram is 150, right? Because what your height will be 160, 170, 180 if you calculate it in centimeters. How your weight will be in kilograms, right? Like 80, 90, 100. So they are close to each other, so we get 150. But if you check your height in meters, which is gonna be maybe like 1.5, 1.6, and weights in kilograms, you get 1.5, even though it is the same relationship, but you are getting a completely different values. So this is not normalized, not standardized, and it's really difficult to compare values this way. Okay. Now, the solution is to use correlation coefficient or standardized covariance. Okay. Now, probably if you worked with machine learning before, you're gonna find something called correlation to get the correlation of some values. So if you write here df.cor and you check the images here, so you might like you have dealt definitely with things like this. And if you didn't, it's fine. We are not we will deal with this again. It's okay. So if you see here, you have like some correlation between two variables. So this is from a website of I don't know, data 36. So here you can see that the correlation here between maybe like height in centimeters and age is this, weight in kilogram, and this is this, so and so on. This is the correlation we are getting. How do you get this? You get this using a simple function from pandas called cor, from pandas documentation here, .corr. We are going to implement this, no problem, but let's first of all see how it works. This works with a method called Pearson correlation, and this is the default method. So method is by default Pearson, okay? Now, this runs a Pearson coefficient correlation. Pearson is a standardized coefficient correlation. What does this mean? It means that it is calculating the correlation between two columns or two variables, but keeping in mind to standardize it. And it calculates the normal covariance, total normal covariance that we know about, and it divides it together with the standard deviation of x multiplied by the standard deviation of y. Okay? So if you check from here, covariance formula, uh, Pearson correlation, so you're gonna get something like this. So this is the correlation covariance from different websites here, okay? And you can see that it's the covariance that we calculated previously, but we divided by the standard deviation of x multiplied by the standard deviation of y, and this to avoid any issues related to different scales of the data. Now, this will help us getting a good results, and the results will be usually between -1 to +1. So they are not increasing like crazy, 150, 170, or maybe in thousands if you have bigger scales. So standardized measure always between -1 to +1, okay? Now, perfect positive is +1, which means that, again, both are increasing together. The one increasing might lead to other one increasing, or yeah, the one increasing might lead to another one increasing. Let's save this like that for now. And 0 means no correlation. -1 means perfect negative, which means they are not no, like one is increasing, one is reducing. Okay. Now, if we take some examples here, okay, if we take things like we are having a Pearson correlation of positive 0.9, which is between height and weight, it means that it is strong positive. Now I'm giving you just some examples, okay? Minus 0.8, it means exercise and body fat, which means strong negative. So minus 0.8, which means more exercises you do, the more body fat you lose, okay? And a very small one, 0.1, shoe size with your IQ. So how your shoe size is related to your intelligence quality or your IQ. it's zero point 0.1, it's weak or no correlation, which is obvious, right? And you might be wondering why it's not zero. So it should be zero, right? Yes, it should be zero. But in some cases, you might have a bigger data set where there are some human errors in the data set or something like this, which could lead us to small values. And again, we're going to learn more about filtering the data. So that's why we're going to have here zero or no relation, zero or weak relation. Now, there is something called causation or causing, okay? You must understand one thing, guys. Correlation is showing association, not causation, okay? Now, what is this? What I'm saying? So, what I mean here is that when we go back here, okay, height and weight in this case, they are not necessarily causing each other, okay? And this is one thing you will need to know. So the more height you will have, the more weight you will have. Yes, okay, fine, but this is not happening because of this, okay? So you are not going like this has happened because of this one. So height is increasing because weight is increasing. No. So let's say you are eating a lot, so your weight got increased, your height will increase? No, not necessarily. Okay? And the opposite as well. Your height keeps increasing, but your weight might be constant, right? So what we are saying here is association. In most cases, they are associated together. So let me give you here another example, clear example, okay? Now, if we check together two data sets or two columns, ice cream sales and drowning death, how many people died because of drowning and how many ice creams are being sold. So if you check the correlation, it will be high, right? Because why would it be high? Okay, because the more ice cream is being sold, we always find more people are dying because of drowning. Now, does this causing this? No, they're not related. But the only thing is that ice cream sales are increased in summer and drowning deaths are also increasing in summer because in summer people are going to beaches, are going swimming, so there is high risk of drowning, right? The more people are swimming, the more people going to beaches, the more drowning people we will find. It's unfortunate, of course, but I mean, this is the case, but they are not related together. So people are not drowning because they are eating ice cream, right? So this is what I mean here. Number of firefighters and fire damage. So they are positively correlated. So if we have a higher fire damage, we might get higher. We will get more firefighters to like try to reduce the things, to try to reduce the problems, the issues. But does it mean that the firefighters are causing more damage? No, it doesn't mean that. But whenever we have more fire, we see more fire, we will see more firefighters, right? So that's the thing I want you to understand. It's not causation or not like happening because of this. It's only they both happen together and the more like they both increase together. This is what I want to say. Okay? Great. Now let's let's finalize this. Okay? Now before we come here, the pandas correlation is Pearson. Pearson is the most popular one and the most used one. There are other ones. We will not go into this for simplicity. If you want, I can add another lecture later for adding the explanation of these. But we usually use Pearson, and Pearson is more than enough. So correlation quantifies relationship strength. So another revision for you. The correlation is simply finding how two variables, how two things are correlated together. It means the direction of relationship. It doesn't mean causation. Okay? So direction of relationship. Remember always, people are drowning, high amount of people dying because of drowning in the sea. In the same time, more people are buying ice cream, but they are not happening because of each other, right? They are both happening because of summertime, okay, or maybe because of the increase of the temperature. So positive correlation means variables move together. Move together means they increase together. Negative correlation means they move in the opposite direction. And we usually the covariance is not standardized, the correlation is standardized. Okay, great. Thank you very much, guys. I hope you enjoyed this, and let me know if you have any questions.